Good morning, friends. We are discussing fluid kinematics of module number 2 in fluid mechanics. What is kinematics? It is that branch of science dealing with the motion of the fluid particles without considering the forces which are responsible for the motion of the fluid. So we bother what is the end result, that is the motion of the fluid, how it happens, but we don't bother which are the forces and how the forces are responsible for the motion of the fluid. So velocity at any point in the flow field at any given time is given due consideration in fluid mechanics. So once the velocity is known, then pressure distribution and the forces acting on the fluid will be determined. So the fluid motion will be described by two methods here, Lagrangian method and Eulerian method. So Lagrangian method, a single fluid particle is followed during its journey. So the observer is fixed to a single fluid particle. So its velocity, acceleration, density, etc. will be observed. But Eulerian method, the observer is on the ground. He is observing all the fluid particles in the fluid flow. Here Lagrangian, so the observer will follow only the movement of one single particle till end. But here the observer will fix to one position. But here the observer will move on as the fluid particle will move. So in Eulerian method, the velocity, acceleration, density, etc. will be described at a fixed point in the fluid flow. So velocity and acceleration for the fluid flow. They are the vector functions used to explain the fluid kinematics. We have here the velocity and acceleration components in three mutually perpendicular directions, x, y and z, considered as the space coordinates, and we have the time interval t. So these velocity and acceleration components are depending on these space coordinates and time t. So the velocity components in these three different directions x, y and z will be considered as u, v and w respectively, and the resultant velocity will be taken as capital V. Then we can represent the velocity components in x, y and z directions as u is the function of x, y, z and t. All the three coordinates, space coordinates and time interval t. Similarly, v is also function of x, y, z and t. W is also function of x, y, z and t. Okay, we are considering the resultant velocity in these three directions and accelerations as ax, ay and az. They are given by the following relations. V, the resultant velocity. So the vector equation ui plus vj plus wk, that is square root of u square plus v square plus w square. So acceleration ax, so it is du by dt. Distance traveled by time taken is the speed. So this is velocity by time taken. So du by dt. So if we write the partial derivation of this du by dt, we have del u by del x into dx by dt plus del u by del y dy by dt plus del u by del z into dz by dt plus del u by del t. So partial derivatives of du by dt, where this dx by dt, that is distance traveled by time taken in x direction. So that is the velocity component u. Similarly, distance traveled by time taken in y direction dy by dt. So that is the velocity component. So that is W, and dz by dt. So that is the velocity component in z direction, that is taken as v. Similarly, ay, acceleration in y direction. So that is given as dv by dt. Its partial derivatives are written here as we wrote ax, that is acceleration in x direction. Similarly, we write acceleration in z direction. So that is the dw by dt with their partial derivatives. Now replacing the ratio of distance by time taken by the velocity components, that is uv and w. So this is u now. So u into del u by del x. Then this is now w. So that is del u, w into del u by del z. Then v into del u by del y plus del u by del t. Similarly, acceleration in y direction. So that is dv by dt. So it is written here, and then acceleration in z direction dw by dt. So we have the set of three equations here. Equation 2, accelerations in x, y and z directions. Then the above equation under steady flow, if we consider the flow as a steady flow, then there will be no change in the velocity with respect to time. So that is del v by del t is equal to 0. So del v by del t in the earlier equations will be taken as 0 here. So then del u by del t. So considering this equations, so if del v by del t is 0, del v by del t is 0, so then dv by dt we have here. So del u by del t, del v by del t, so del u by del t is equal to 0. That is this velocity, resultant velocity v with respect to t is 0, means its three components in x, y and z directions are also 0. So del u by del t is 0, del v by del t is 0, and then del u by del w by del t is 0. So substituting this in the equation 2, so we are getting the simplified versions of ax, ay and az. So a set of three equations. Equation 3, acceleration vector A is equal to this ax1, that is axi plus ayj plus azk. So that is square root of ax square plus ay square plus az square. Equation 4. Thank you.